When we need to write the equation to represent a exponential function that's a scenario in words, or a table or a graph, there's two key pieces of information we need to know. The first thing we need to know is what is the initial value, which is also known as the y-intercept, which is also, you can find it when x equals 0. What's that initial value? That's going to be our a value in the equation, y equals a times b to the x power, or f of x equals a times b to the x. The second piece of information we need to know is what is the common multiplier or the common ratio value, and that's going to represent the b. So we can see that in a table. We can see that on a graph. We'll talk about how we can see the b value in the graph. And then in a written scenario, it's usually in the word somewhere. We have to figure out what is that common multiplier that we are using, and how we write that as a number for b. All right, so those are the two things we need to know no matter what form we're given of the exponential function. Let's begin with tables. So example 1, here's our table. We have an XY table, 0, 4, 1, 2, 2, 6. All right, so let's figure out the a value. In this table, it's real easy because they give us when x is 0. So they give us the y-intercept. The y-intercept is right here. So our a value is going to be 4. All right, the b value, what's that common multiplier? So 4 times what is 12? 12 times what is 36? That's one way of doing it. Or you can go 12 or 36 divided by 12 is 3. 12 divided by 4 is 3. So our b value is 3. All right, name that function. We just substitute those values into our equation, y equals a times b to the x. So this one is going to be y equals 4 times 3 to the x power. Look at example 2 now. We have the equation 1 comma 6, 2 comma 12, 3 comma 24, and 4 comma 48. Now this one's not as easy as the first one. We're not given the y-intercept in this table. So let's start with actually figuring out the b first. What's the common multiplier? You go 6 to 12, 12 to 24, 24 to 48. What are they multiplying by each time? That's right, we're multiplying by 2. So now what we need to figure out in the table is when x is 0, what's y? Well, what do you do when you go reverse engineer this, right? You go backwards. 48 to 24, 24 to 12, 12 to 6. What do you multiply when you go backwards? That's right, you're multiplying by 1/2. Or you can think of it as you're dividing by 2 each time, right? So what's 6 times 1/2? 3. What's 6 divided by 2? 3. So either way, we're going to get 3 there. So this means our a value is 3. Okay, that's the tricky part. So you need to know the y value when x is 0. Okay, so it's not always given in the table. So you have to figure that out. All right, so now that we know that, now we can write our equation easily, right? Name that function. Y equals 3 multiplied by 2 to the x power. There it is. Okay, let's look at our example number 3. We have a table. Ooh, this time I put the table horizontal versus vertical. Can we handle that? Sure we can. So when x is 0, y is 64. Oh, bingo, they gave us the y-intercept. So our a value is 64. Ooh, look at this one. This one's not increasing like the others. This one's decreasing. It goes 64 to 16, 16 to 4, 4 to 1. So 64 times what is 16? 16 times what is 4? 4 times what is 1? Or, if that's hard, you can also go reverse engineer it. 1 divided by 4 is 1/4. 4 divided by 16 is 4 over 16, which is 1/4. 16 divided by 64 is 16 over 64, which is 1/4. So our multiplier, our common multiplier, is we're multiplying by 1/4. All right, name that function. Y equals 64 multiplied by 1/4 1/4 to the x power. If you want to put 0.25 instead of 1/4, by all means, you can do that as well. All right, let's look at our last table example. We have 117, 251, 3, 153, 4, 459. Oh my gosh, it's getting big real fast. So again, we don't have the y-intercept this time. So let's start off figuring out what the common multiplier is. 17 times what is 51? 51 times what's 153? 153 times what is 459? I'm going to get 3 for B. I could have also went 51 divided by 17 is 3, or 153 divided by 51 is 3, or 459 divided by 153 is 3. So now, interesting, how are we going to figure out the y-intercept when x is 0? Well, 17 divided by 3, right? So it's 17 thirds. Yeah, it's not pretty, but I'll leave it at 17 thirds. That's fine. 17 thirds. All right, let's name that function. Y equals 17 thirds. That's our initial value, the y-intercept, multiplied by 3 to the x power. All right, let's look at our first graph here. So what's beautiful is if they give you the y-intercept, then they're giving us the a value. So we can see this one crosses at 0, 2. So we are going to have a value be 2. Now the b value, you can figure out similar to how we just did with the tables. If you have discrete points on the graph that you can read, so clear lattice points. So for example, we have 1, 6 here we can read. We have 2, 18 we can read. So think about it. When you go from 2 to 6, what did you multiply by? 2 times what is 6? That's right, 3. And you went from 6 to 18. What did you multiply by? 3. So our b value is 3. If you like the table better, that helps you visualize it, you can rewrite this as a table to see it, right? So you'd have 0, 2, 1, 6, and then 2, 18. That helps you process it better. By all means, create a little table of values and do it the way we just did it the previous examples. All right, so name that function. Y equals 2 times 3 to the x power. Look at example 2. Again, we have our y-intercept is at 0, 2, so we know our a value is 2. But now the b value, you got to be careful here. See, this one's actually decreasing. Our values are getting, our y values are getting smaller as x gets larger. So we want to start from the far left, the point that we know. So we know that the y value is 8, then it's 4, then it's 2. What are they multiplying by each time? That's right, a half. So they're multiplying by 1/2. Again, if you need a table of values, it helps you see it. You write it as -2, 8. Oh, you don't need a comma for a table. -1, 4, and then 0, 2. All right, so 8 times what is 4, 4 times what is 2, or you reverse engineer it. 2 divided by 4 is a half. 4 divided by 8 is 1/2. All right, so now we know our a and our b, so we can name that function f of x or y equals, depending what notation you need to use for the problem. So y equals 2 times 1/2 to the x power. Look at example 3. This one is a little bit hard to read, the y-intercept, but we're going to say that that is 1/2. It's between 0 and 1, so a is 1/2. And then it goes from 1/2, it goes to 2, and goes from 2 to 8. So 1/2 multiplied by what gets you 2? That's right, 4. 2 times what gets you 8? 4. So our b value is 4. Again, if it helps you, you could rewrite it as a table of values, which would be 0, 1/2, 1, 2, 2, 8. And you go, as you work this way, we're multiplying by 4. If we went the other way, reverse engineer it, 8 divided by 2 is 4. 2 divided by 1/2 is 4, and so on. All right? So name that function. It's either y equals, or I can say f of x. Let's do f of x this time. F of x equals 1/2 multiplied by 4 to the x power. Let's look at our last graph example. So the y-intercept on this one is 27, so our a value is 27. And then what's going on? It goes from 27, boom, all the way down to 9. Boom, down to 3. Boom, down to something like, I'm not quite sure what that last one is. I have a guess, but I'm not quite sure. So 27 to 9, what do they multiply by? 1/3. Or you think of 27 divided by 3 is 9. Dividing by 3 is the same as multiplying by 1/3, and we want the common multiplier, not the common divider. Okay, so it's a multiplier. So it's going to be 1/3. Again, 9 times a third is 3. So 3 times a third, that tells me that value is actually going to be 1, which is what that next one would have been. All right, so name that function. F of x equals 27 multiplied by 1/3 to the x. So I just want to point out again, I know we talked about in the past, when you see the b value here, when the b value is between 0 and 1, we get this curve that's coming down, is decreasing when the a value is a positive value. And then when we have the b value that's greater than 1, then it's an increasing curve, and our a values are always positive in this scenario as well. So I want you to recognize that. So it's going to be decreasing when that b value is between 0 and 1, and it's going to be increasing when that b value is greater than 1. All right, let's look at the written scenario here. A bank account starts with $5 and doubles every month. So from the words, we have to be able to figure out what part is A, what part is B in order to write the function in the form f of x equals A times B to the x. So the bank account starts with $5. That's our initial value. A is the initial value, so that is our 5. Now, it doubles every month. What does that mean as the multiplier? What number do we use to double something? That's right, 2. So we are going to have b as 2. So now we write the function. It's going to be simply f of x equals 5 multiplied by 2 to the x. It says evaluate the function, determine how much money you'd have after 8 months. Well, the initial value would be at month 0, right? And then you go 1 month, it doubles. 2 months, it doubles again. 3 months, it doubles again. So this is like saying f of x is 8, so f of 8 equals 5 multiplied by 2 to the 8th power. Okay, I took a quick pause to do the math in my head. So I get f of 8 equals 5 times 256. Where did the 256 come from? That's 2 to the 8th power. And I just did that in my head. But if you want to use a calculator, that's where you use the 2 caret key to get raised up to exponent to 8 on your calculator to get the 256. And then you have to multiply 256 times 5. Remember from yesterday's lesson, the order of operations, we have to go 2 to the 8th first before we multiply by the 5. So f of 8 equals 1280. Let's look at one more example for a written scenario. So here's our example. There are currently 20,000 owls in the wild. Every decade, the number of owls is halved. All right, write the function in the form f of x equals a times b to the x. So in this problem, our current number of 20,000 owls, that's our initial value, correct? So that's our a value. So a is 20,000. And then every decade, so our period of time is a decade. So 1 is 10 years, 2 is 20 years, 3 is 30 years, and so on. But every decade, the number of owls is halved. Well, halved means 1/2. So b is 1/2. So our function is f of x equals 20,000 multiplied by 1/2 to the x power. All right, now it says evaluate this function, determine how many owls there will be in the wild 5 decades from now. So that's 50 years from now, 5 decades, but we're going to use 5 to represent x because this was all based on number of decades. So 5 is our x value, so we're going to say f of 5 equals 20,000 multiplied by 1/2 to the 5th power. So we get f of 5 equals 625, and yes, I did cheat and use a calculator. So I could do the 1/2 to the 5th power in my head, which was 1 over 32, but then 130 over 32 times 20,000, I couldn't do that in my head, or I didn't want to do it in my head at least. So I get f of 5 equals 625 owls. So there'll only be 625 owls remaining in this model after 50 years or 5 decades. All right. That's it for the notes today.